This video file was recorded in Sabunja University during recitations for the CS204-Advanced programming course as it was given in the spring semester of 2017.
Hello everyone. Welcome back for the fourth week of Advanced Programming. And since you don't have questions, we can continue with new topics for today. We're going to cover some stuff that we have already seen, but also we are going to see some new stuff. Namely, we're going to cover static variables today. We're going to cover pointer passing. We're going to cover also external variables, and we will do some stuff with linked lists. Namely, we're going to introduce to you the circular and non-circular linked lists. Hope you have downloaded your codes. Let's start a new project from scratch. Let it be an empty one. We will start with a static local variable. So please copy the CPP file to the solution folder of the project that we are just going to create. Okay. I'm going to paste it here, and I'm going to include it to add it to the solution folder. Now, we have seen static variables in CS201 in the Introduction to Computing course last semester, or those that took this course few semesters ago also saw it. Do you remember what are static variables? Can you tell me? Static variables.
Variables cannot change.
Variables that cannot change. Are you talking about constant variables? Because constant variables, you cannot change their values. They're always constant. But those are static variables. So what is interesting about them? Very briefly, let's say that in main I've declared a variable. Let's say not a variable, I'm calling a function f1. So I have some code here, okay. So this is main. Let me do it in a more polite way. I have some code here, codes here, and I call function f1. When I call function f1, in f1 I have, let's say, an integer variable a, and I put its value to be 5, initialize it, and a static integer b, and its value is 3. So let me write f1. f1 might look something like this. Integer a is equal to 5, then I say a++, then I have static integer b equal to 3, and then I say b++. This is void. So this is what this f1 is doing. So I call f1. Again, I have some codes after calling f1 in main. Then I call f1 again. Then I have codes. Then I call f1 for the third time. What is going to happen? When I call f1 for the first time, so we are here now. When I call f1 for the first time, we have an ordinary integer. So this is in main, this is in f1. In f1 I declare this a, and I put its value to be 5. Then I increment a, and a becomes 6. Then I declare a static integer b, and its initial value is 3. So I'm going to write it. Static b, its value is 3. I increment b, and it's 4. Now it's 4. When I finish with f1, everything that is associated with f1 is going to be erased, except for this guy, the b variable. And it stays as it is. Okay? So I go in main here. I continue where I stopped. I execute those pieces of code. Then I call f1 again. So I call f1. Now I have another variable, a. I declare it. The value of a is 5. I increment it, now it's 6. But when I go to this static variable b, we already have it there. It's not deleted. We have it from the previous time. So we initialize and declare it only once at the first call of the function. So this line here is going to be executed only once, when we call the function f1 for the first time. Now, the compiler sees whether we have already called f1, and it figures out that we have already called f1. So we have static b. That's why this guy is not going to be executed again. It is executed only once at the first call of f1. That's why we immediately go with the second line. And what do we have in the second line? We have b++. So b is going to become 5. Now f1 finishes, and everything associated with it is going to be erased from memory, except for this static b. It stays there. We go here, so we are finished with the second call. We execute some codes in between. We call f1 for the third time. When we call it again, we have a. This is executed again from scratch. Initially it's 5. Then with this line of code, we have a++. It's incremented to 6. So we have for a 6 now. We check, do we have b? Yeah, we have b. We're not going to execute this line. We go directly to the fourth line actually of the function. We increment b, so b is also 6. Okay? The function is finished, the static is left there up until the program is terminated. Okay? Do you have a clue what static variables are doing? If you remember, we did this in CS201. Do you remember it from CS201? Okay. If that's the case, a question?
Static variable can be anything, right?
Yeah, they can boolean, strings, whatever. We will see an example with string static variables. So let me run the code, let me see the output, and I'm going to explain it. What's happening here? So this is my code. I'm going to run it. Let me enlarge the font also. So you see, first call, I assign some value, I update the function, then I call it from the second call. You see, this part is updated in function, updated in function, updated in function is repeated, because we are using static variables. So let's go and see what's happening here in the program. We have a function called magicalFunction. Here we declare a static variable of type string. Initial value of that string is first value assigned, okay? Then we print it. Then we append. Append means we put in the end this stuff. Update it in function. So first value assigned point, update it in function. We append it in the end. We print it again, okay? So this is what the function is doing. In main, we are calling this function twice. Once here, once here. We can make it thrice, 3 times. But I don't, okay, we can try it. So let's see how did we get this output that we saw. So let's start with main. And let's see also the output at the console. This is our output. So we print here, first call. Then we call the magical function. But let me remind you that this guy is in main. So from main, we call the magical function. I'm going to write it as mf. And here we have mf, the magical function. In MF, we define a string variable which is static. So I'm going to write static. The name of the string is static local string. I'm going to write it as SLS, an abbreviation of static local string, SLS. Initially, its value is what? The value of this guy is first value assigned. First value assigned. Then I print it. And I see it at the console. First value assigned. Then I add this stuff in the end using the plus equal operator. So I add updated in function. And I print it again. So I have first value assigned, which is repeated, and I have updated in function. The magical function is finished. We don't have to return anything here. But this guy is not going to be erased since this is static variable. So we go here, we left here, and the compiler knows where we left. And it knows because of stacks. And what are stacks? We are going to see on Monday. We go here, we print second call. Now again, we call the magical function. But when we go to the magical function, is this guy going to be executed the first comment? Yes or no? Is the first line going to be executed? Why? Because it's static. If we already have it, it's executed only once at the first call of the function. Since we called it previously at the second call, the declaration is not going to be executed. Okay? That's why we go here and write what? We are printing first value assigned. We are printing the static local string. So updated in function. We print this guy again. Updated in function, blah, blah, blah. Then we add updated in function again. Point updated in function. And we print it again. So we print that again. Having this guy updated function in the end twice. Okay, and this is it. Let's see the output again. See? Same. Assigned, updated only once, updated twice. Assigned, updated once, updated once. This is it. Questions? Okay, you might think that why do we use static variables? They're very important in some places. You'll see where. In like 2 weeks, 3 weeks from now. Okay, it's not to complicate your lives. We love you. Okay, although we give you hard assignments maybe, but we do it for your purpose, to help you learn programming. But static variables really make your life easier, and you will see why in a couple of weeks. If there are no questions, when I do this stuff, when I'm finished with the program, I can erase the static variables. They're not forever there, fortunately for us. They live up until the program lives. Now let's go with something else. And if you understand this example, and I'm warning you, this example is going to be a bit complicated and important. And I expect that you'll have something about it in midterm, yes. Maybe in final, or maybe in both. So pay attention to it, because you make a lot of mistakes. As you have seen your homework, I suppose that you made a lot of mistakes, and There were a lot of unclear stuff with the pointers. And you'll see some of the mistakes that you make here. We are going to see, because you pass the pointers as a parameter to the function, okay, and you are confused, okay, what happens? So we are going to see how it works actually. When you pass a pointer as a parameter, a pointer to a pointer, a reference to a pointer, and so on. Your second homework is going to be much harder. That's why I understand how it works. It's not related to your second homework. It's related to pointers and pointer passing as parameters and so on. But it's important to know how things work. I'm also warning you that something similar to this is you're going to see in your exams. This is what I expect. So pointer passing is going to be our second example for today. Just copy paste the CPP file of the same solution folder and add it as an existing item to the project. Let's see what's happening here. I'm going to run the code. We'll see the output. This is the output. And we are going to explain how did we get this fancy, this crazy output, and how it works. At first, let me explain very briefly what the code is doing. So we have the main function here. In main, we call another function which is called do this. It takes some parameter. And this is how the do this function is doing. It returns nothing. It's a void function. It takes a pointer to a double, a pointer to an integer variable, a pointer to a string variable. And what is this? Can you tell me? Yes, a reference to a pointer variable, or reference to a pointer of integer type. Okay, so pointer and reference. Where's the difference between only pointer and reference to a pointer? We will see in this example.
Does it matter if the end symbol is before the...
Make it like this. Sometimes it matters, sometimes not. Make it like, don't complicate your life. So you first write the star and then you write the reference, okay? Let's see what's going on here and how did we get that crazy output. We are in main. And in main, we declare a string. So we have S. Its name is S. Its value is CS204. With the second line of main, let's go. First, this part is executed. We say new double. So what the compiler is doing is the following. We have a double. It has no value, but we have reserved a memory block for it. Let's say its address is 100. I'm making the addresses. So the address is 100. And this new returns the address of the double. So we have dptr, and this is a pointer to the double. And its value is assigned here. That's why we have this is equal to the address of the newly assigned, of the newly created block memory of double. And it points here, okay? Then, we have new integer 2. We have this stuff. We have an array. This is index 0. This is index 1. Let's say this guy has an address of 150, and I'm making it up. This guy has an address of what? The second one. 54, yeah, because we need 4 bytes. So the starting place of the second address is 154. Those are the indexes. Don't confuse it with addresses. With this new, we return the first one, 150. And it's a pointer to this guy. It's called integer pointer 1. it also has a memory block, because we should keep the address somewhere. So it's 150, and it's pointing to this 150 here. Then we have another integer pointer 2. It is just showing integer pointer 2. Let's say that the value of this guy is 200, and I'm assigning random numbers. We don't have any value here. We don't have the name for this variable, neither for this one, neither for this one. We can access them by the pointers. And we have an integer pointer 3. So this is integer pointer 3. And it's equal to integer pointer 2. Basically, its value is 200. And it is pointing here. So far, so good. Now let's go with those 4 lines and see what we are doing. What we are doing with this line here. Start dptr is equal to 3.14. Yeah, say it. Exactly. The value to which dptr is pointing, and it's pointing to 100, the value of this 100 is 3.14. Then we say eptr1 of 0 is 10. We're doing this stuff. We have 10 here. eptr of 0 is 10. eptr1 of 1 is 20. So we have 20 here. The value of eptr2 is 2. So we have 2 here. Okay. Now we call the do this function. So this is do this. We send dptr, we send it here, but pay attention, always when we send parameters to a function, always we make a copy of it with the value it has in its box. Except when we are sending a reference. When we send a reference, we don't make a copy of it. Okay, so here we are sending dptr, and you see dptr is a pointer, it's type, pointer of double. We are making a copy of dptr, which is called dp here. So we have dp here, dp. What's the value of dp? You see it's pointed to double. What's the value of dp? So we are sending dptr. You see, the first parameter here is dptr. The first parameter here is dp. So the value of dptr is going to be the value of dp, and the value of dptr is 100. Not the value to which it's pointing. It's the value of the dptr itself. So we have here 100, and this 100 is pointing here to this address.
Could you repeat this again?
Okay. You see that do this function. The first parameter, the first parameter is a pointer to a double type, okay, and it's called dp. So we have dp here. When we send it here, you see the first parameter that we sent is dptr. Okay, so dptr is basically dp in do this. The value of dptr is 100. Okay, so the value of dp is also 100. We are not sending the double, but the pointer. Then we make a copy of it. Always is done like this. This is not a reference, this is a pointer. So we have a pointer here, a pointer here. Yeah, they point to the same location. Okay, but they're different. They have the same value, 100, 100, but they're different variables. Now we are sending iptr1, and iptr1 is known as ip. So we have ip here. And what's the value of ip? It's 150. So we have 150. And this guy is pointing here. Then we send, this is interesting. We are expecting, what? This is string. This is a pointer to a string. Okay? This string here has its address. Let's say the address of this string is 500. I have not used 500? No. Okay? So when I'm expecting a pointer to SP. So the third parameter is expecting a pointer to SP. And see what I'm doing here. What is this? Can you tell me? Exactly, we are sending the address. When we use this stuff, we are sending the address of it, okay? So we have here, this is not a reference, we are sending the address. So we have SP here. And the value of SP is 500. And this is a pointer to a string. And it's pointing to this guy here. Okay, so it was S in main, it's string pointer SP to do this. And finally, we are expecting, and this is interesting, we're seeing this for the first time in CS204, we are expecting a reference of a pointer. It's called IRP. So, how I'm going, okay, so we have IRP. And what we are sending here, the last parameter is IPTR2, but I'm going to write it like this. This is IRP. Oh, no, I'm sorry. This is IRP, okay? So this guy and this guy are related. I mean, in main, we know this as IPTR2, but in do this, we know this as IRP, okay? We don't assign a new memory block here. We are using the same one. We have seen this in CS201, basically, okay? So we have a new memory block for each of the parameters, but for the reference of the pointer, for this guy, we are using the name IRP. We don't have any memory here. We are using the one that is in main. We don't explicitly allocate a new block. Now let's see what do we have. This is our output. So we print do this begin. Do this begin. And what we are printing now? We are printing start DP. So DP is this guy. We are printing the value to which it is pointing, and it's 3.14, okay? So this is 3.14. Then we are printing IP0 and IP1. So IP0 is 10, IP1 is 20. We have an empty space here, we print 10, an empty space, we print 20. Then we print the value to which SP is pointing, okay, and SP is pointing to 500, so we print CS204, an empty space, and we have CS204. And finally, we print the value to which IRP is pointing, and IRP happens to be the same variable as IPTR2, just with another name. It's a reference. So IRP is 200, and IRP is pointing to a value, the value to which it is pointing is 2. That's why I print 2 here, okay? Now see the first line. Do we have everything the same? Yes, the same. Okay. Now let's go with this part here. We say DP is equal to new double. By the way, all those allocations were allocated with new. So this was made with new. This one was made with new. And this one was made with new, if you remember, okay? We don't have any new here. The new that we are going to use and do this is this one. Double pointer is equal to new double. So we allocate a new double. It's here. Let's say the value of this guy is 600. And now this 600 is returned to double pointer, and it is pointing to 600. So it's not pointing anymore to this address, it is pointing to 600. And we say that the value to which DP is pointing is 5.4. Remember, we made it with new. Okay, I'm writing it. So it's 5.4. Then I'm saying IP of 0 is 100. This is IP. IP of 0, this is index 0. We'll write the indexes here. So this is index 0, this is index 1. And I'm saying IP of 0 is 100. So its value changed here. Then I'm saying SP is equal to the pointer, the value to which SP is pointing is equal to the value of SP plus is easy. What are we doing here? So the value to which SP is pointing is this one. S2, it's 500. It's the value of 500 is CS204. CS204. Here we add that previous value plus is easy. So we have is easy. We go. We say IRP is equal to new integer. But hey, IRP, this poor guy was pointing to this guy. Okay? Those two are the same. When I say new int, I'm creating a new integer here. Let's say the value of this integer is 700. And now IRP, which is IPTR2 of main also, is not pointing anymore to these two, but it's pointing to, we have 700 here, it's pointing to this variable here. And we say the value of it is 200. Okay? It's a kind of a coincidence, but it's 200. So the value of the address 700 is 200. We did it with this one. Now we go in the end and we say do this and we print this stuff. So this is what we see in the console. Do this and let's see, what do we have here? We print the same stuff basically. We print the pointer, the value to which DP is pointing. So DP is pointing to 600, which is 5.4 empty space. Then we print IP0 and IP1. It's 120. So it is 100 and it is 20. Then we print the value to which SP is pointing, 500. It's CS204 is easy. So we print CS204 is easy. I don't have place, that's why I'm going to continue here. Then we print what? IRP. IRP is this one, 700. The value to which 700 is pointing is 200. So I'm printing, let me write it here, 200. Now let's see, is everything the same? With the output that we got, do this and 5.4, 120, CS204 is easy, and 200. So everything is the same. Okay, now we are going to erase. So do this is finished here. And everything that is associated with do this is going to be erased. But which parts? This is going to be erased, SP, the pointer. It is erased. DP is going to be erased also. IP is going to be erased. We don't have it. So every new memory which is not static is going to be erased. IRP is not going to be erased. But this name will not exist anymore in main. Okay? In main, we know it, the same variable as iptr2. Okay? So this name does not exist in main. However, what about this new guy? Is that going to be erased or not? No. In order to erase new stuff, we should use delete. Okay? So delete should be used. If you allocate the memory using the new command, you can only delete it with delete, or if the program terminates. Okay? So this is a memory leakage. Okay? And this is a problem. We intentionally did it in this case here. So static variables, and the ones allocated with new are not deleted. They stay there. Everything else is deleted. Now let's go to main. Any questions? No questions. So we called the function previously, you remember. Now we are here, and we are going to print this stuff. So in main, we are printing what? First I'm printing the dptr. dptr points to 3.14. So we have here 3.14. Empty space. Then I'm printing iptr1 0 and iptr1 1. So basically I'm printing those two. They are 120 correspondingly. 120. Then I'm printing the string. I'll have to change the battery, I'm sorry. Yes. 3.14. I printed iptr1 0 and iptr1 1, the array, 120. Now I should print the S, the string. S is CS204 is easy. CS204 is easy. And I should print iptr2. I'll do it in a new line. So what's the value of iptr2 is? The value to which iptr2 is pointing, star iptr2 is 200, so I'm printing 200. And then I'm printing the value to which iptr3 is pointing, and it is 2. Okay, let me see, is everything correct? So we have 3.14, we have 120, CS204 is easy, 202, okay? Is this clear till now? Yeah, I know it's confusing, that's why you have the video, so you can check it. But you should understand how things work. We're not done yet. Since now we are deleting the dptr. Delete dptr means we're going to delete the... So dptr is a pointer. We're going to delete the memory block to which dptr is pointing. So with this command, delete dptr, we are deleting this stuff. We don't have it. It's not in the memory. When we say delete iptr1, but we have those brackets, and you remember those are for the vectors, for the arrays. Okay? Because when we declared iptr1, we used, remember, new int2. Okay? When we define dptr, we use new double, so we are deleting it. We are deleting also iptr1, and we are deleting all of the arrays to which iptr1 is pointing, all the array, all the vector. We don't have it anymore. And we delete iptr2. So we delete iptr2, we delete this guy. And we are finished. Basically, we go to system pause. Is there any mistake here also? This one is not also deleted. This is also memory leakage. So this one was not deleted, it was created with new. This one was also created with new. But you remember what we did? This pointer pointed to another memory location, so we deleted it. But this one new was created in do this function. Okay? But we are not deleting it here. And this is memory leakage. So those two guys are a problem. And if you happen to be a web developer or a programmer, and you run out of memory, and you shouldn't, probably one of the reasons might be this, which is called memory leakage. If you assign something with new, you can delete it only with delete. Okay? Or if the program terminates, the application terminates, they're of course going to be deleted. And this is called garbage collection. Also remember this name. Meaning the compiler itself, the operating system, is going to free those blocks. Okay? Any question about what we have done so far? Yes?
I think the professor said something about the deleting the arrays. Like if we don't want to delete the whole array but
Yes.
only one element, how would the syntax for that would without the bracket?
Without the brackets. Yeah. If you want to delete only the second one,
That deletes the first or the last one?
the first one, because IPTR is always PTR1 is always pointing to the first one. Okay. We explained this last week, if you remember, or maybe 2 weeks ago. We have another example. I wanted to cover it during this class, but I think it's good that we devoted a lot of time to this example because it's very critical and important to understand this pointer passing stuff and stuff we did with the pointers. You make a lot of mistakes with the pointers and references of pointers and whatever. That's why I think it was important to explain it briefly, deeply. Okay, you'll have 5 more minutes of break, and we will be back for the second class.